Okay, welcome. See, I'm Bryan Holland, and today I'm going to take you into a little bit of a wayback machine. We're going to learn about some old technology, some old databases, and how we can kind of leverage the data that's in those old databases with kind of current tooling and stuff. Again, I'm Bryan Holland, and I'm with Software Concepts International. Kind of an interesting piece of uh, why am I talking about this ancient technology? So I started, I'm actually the founder of SCI. I founded it back in '87, so a long time ago. And the origins of the company actually were providing support really specifically for this CODASYL database. And a number of customers running applications like the workstream application, MES application used widely in the semiconductor industry. And Man were a couple of well-known applications at the time that were using this database. The company has since evolved to provide support for other databases, and probably one of the premier providers of support for the OpenBMS, platform itself. So, but our company, what we do is manage OpenBMS and databases, and our customers, as we're managing the databases and stuff, have looked at how can we, in these CODASYL databases we talk about, how can we extract the data out of these ancient databases? How can we start to use modern tools, et cetera? So, what we'll talk about in today's session really is just, if you're not familiar with kind of what a CODASYL database is, maybe you are, maybe you're not. Oh, excellent. So we have a few historians here. But where is CODASYL used? Why is it still relevant in 2025, despite what the slide says here? Kind of the concept of log mining. Okay, what is log mining, and why would you want to log mine a CODASYL database? Or maybe a better question, more interesting question might be, how the heck would you log mine a CODASYL database? Because it seems it's a little bit different than what we're used to today. How does it work? How does it perform? If we're getting this data out of this old CODASYL database, what's the impact on our production system or the target system where we're trying to get this data into? Because I stole a little bit of thunder before. The CODASYL is used. We have a number of customers running the workstream application, and we support customers around the world, running workstream in their databases, and a lot of them are using Transcend as a way to kind of modernize and have access to the CODASYL data directly. We have customers that are running the Man application as well, and using Transcend to, again, have a modern interface and be able to do reporting in real time, data information. You can see that, it's used in a whole bunch of different places, actually, different industries. All right. So, it's good to hear that people are familiar with the CODASYL databases. But CODASYL actually comes out of CODASYL's Conference on Data System Languages. Okay, and it's actually the same body that created the COBOL language. And everybody knows that COBOL is the most widely popular, language used in development today. Sarcasm. But the funny thing is the CODASYL committee actually is disbanded. They no longer exist. So the database is actually outlived the committee that created, specified the database. But you can still see this in probably like the Charles Babbage Museum and stuff. But the CODASYL model was really, predates the relational stuff. So they didn't really kind of figure out how, we can create relationships between tables by simply using the data in the tables. Is really more of the idea of, of linked lists. So I can have these concepts of, I have an invoice record and I have a bunch of detail records, and how do I create a relationship between those? Well, I'll create a linked list. So I'll start with that with this inventory record. And physically in the inventory record, I might have a pointer, physical pointer to the address of the first detail record. The first one would have a link to the next one, and the next one, and the next one. And that pretty much defines then really the methods in as you're accessing the data within a CODASYL database. It's really very procedural, step by step. In the CODASYL database, then all the relationships, or the key relationships, I should say, between the data really have to be pre-mapped and predefined by the person who originally developed the schema. So they say, okay, if I'm going to go from the inventory record to inventory detail, okay, then I need to have, create something called a set, okay, a named relationship now between these two data, but this named relationship is really just a name for these pointers, it's this linked list in between. But as a programmer, then people would have to say, well, if I'm going from the inventory record to the inventory detail record, it's not select these things where the values match. It's, we'll fetch the first inventory record. Okay. Now fetch the next detail record, but I have to follow the set within set, and then you have to give the set name. Then it's going to go and get the the first detail record. So it's very procedural. It's very the person who's programming for the CODASYL database has to have a lot of intimate knowledge about the structure of the database. So so the primary the interface into DBMS, CODASYL DBMS, is via this DML. So the important thing is not SQL. So nobody coming out of college today is going to know that. There's no tools other than we'll see what the languages are that you can access it through. But really, it kind of creates this silo. Now it works great. If your only thing you want to do is run the your workstream application, your man-man application, or whatever your application your customer is running, and they don't really need access, kind of the OLTP portion of that, it seems to do a great job and it's very stable. But if all of a sudden it's like, the world's evolved, I want to have different reporting stuff, it's like not so easy any longer. So show here kind of an example of just kind of what DML looks like. Has anybody have you done any programming in like DML? No. Okay. All right. So all right. But again, you can see it's here fetch the first part within, and again I can't just say fetch the first part where the part number equals XYZ, right? It's like, okay, but you can, but then the DBMS might say we're going to just walk the whole database to kind of find it. So you got to you got to tell it, okay, I have to have knowledge about the database besides the columns and stuff. Find the next inventory record within the part inventory. Very procedural, very step by step. And then the other thing is that from kind of an efficiency standpoint, a lot of the databases today do a lot of optimization of how can I optimize the query that you're saying. So a couple things. One is that depending on the cardinality of your different data, relational database might say, hey, this is a more optimal path to get the data than using these indices over here. Yeah. So
Bryan, were you saying there this doesn't have the optimization mechanisms that were built in?
No, because it's really it's kind of like it's kind of like the difference. It's very procedural. You have to tell it step by step how to get the data. Okay. And then the other part I was going to say on the optimization side is that within relational databases, they can go scan an index and say, okay, well, not only do I know where the next record is, but I can guess pretty well where the next 100 records are going to be. You can go prefetch that data. So before you even ask for it, the relational databases can go off and kind of prefetch the data so that when as they're going through and scanning, collecting the data, the data is already in memory as opposed to going off the disk. Whereas if you're following a linked list, what do I know? I know the guy that's, I know what the next guy is. So I can get here, but I don't know Ken out here. It's, the next one. So there's lots of optimizations that you can't do, in a CODASYL database that you can in modern relational databases. So again, if you're very talented with COBOL, Fortran, all the modern languages, you're gonna feel home with CODASYL PBMS, and you can even use some C, lists, basic Ada, Dyball with some free compilers, and then you can probably make up your own with there's a callable DBQ interface. So DBQ is kind of like it's CODASYL's version of interactive SQL. So. All right. So if we thought about my prior fetch statement, in a relational database, it's kind of select the location and part description, from what table I'm going to get it, join on this table based on the part numbers match. What a concept. Okay. But with this statement here, I'll get a list of inventory records as opposed to in the CODASYL database, I get the first one, then I have to basically repeat the statement, loop through for every detailed record. Unsurprisingly, turns out there was actually a lot of valuable and important information that's stored in these databases. Okay, and customers wanted to get access to it. So. So, obviously, customers want to use modern tools. They don't want to be locked into, the reports that either Man has provided or Applied Materials for the workstream application provided, but they want to say, hey, listen, it's my data. Let me drill down to it and get access to it as I want. Or they want to feed some downstream systems. Okay, so I want to take my workstream data and then send that out to the rest of the our enterprise for analysis. All right, and then the other thing which is kind of nice, and I think VMS kind of suffers from this as well. But how can we avoid kind of the critical eye of the legacy system? So everybody's like, it's like we got to get rid of this because we can't do reporting on it. Well, so what if you could? I mean, the wonderful thing is these things are like rock solid. I mean, they've been working for 30 years, but now you can actually if you can get data out of them, then that would be even better. All right, so log mining. And I'm going to jump ahead just a little bit, and then hopefully I'll remember not to repeat it later. Okay. But so in this CODASYL world, how have people been getting the data out? Well, we talked about the DML as kind of a laborious programming process going through. But one of the things that our customers were doing before was going through in what I call data scraping. Okay, so they might run a program every 2 hours, which would run for approximately 2 hours, and essentially traverse the whole database looking for, what's changed in the last 2 hours? It's like, again, I'm going to create a file or whatever, update some file of this is kind of current data stuff. It's like, well, it's pretty hard on it's pretty hard on the application or on the system because you're doing a lot of I/O. There's a lot of locking on the database, so you're interfering now with the production operation because you're trying to run this kind of silly report. So kind of the concept of log mining, by contrast, is in every serious production database. Okay, the customers have journaling enabled. So journaling basically allows you to say, to recover the database back to, the intent of it is to allow you to recover the database back at any point in time. So if I have a failure, if I do a backup, let's say once a day, and there's a failure 6 hours after that backup occurs, and I need to recover the database, I can take that backup, and then I can roll the journal transactions forward and then get back to the last committed transaction. So we don't lose any data. So the idea of log mining is, rather than going through and scraping the database and looking for things that have changed, we already have a log of all the changes. So why don't we take that log of just the changes, and we'll use that as a way to extract the data out. So now we're really only looking at the changes, and we're not even touching the production database at this point. So, kind of from, there's no impact on the production database because we're not touching it. And you don't have to write new programs. You don't have to change your existing program. It's actually interesting, within the workstream application, they had these little hooks in the application where every time they would modify a record, they would actually, have the option to write it out to a message bus, and then message bus would go through. I mean, it was a creative but very complex, set of machinery that they did to do that. But again, it's kind of embedded in the application. So the application is taking time and performance away from the application to do this. Not necessary. So with the log mining, it's efficient because the journal only contains the changes. As we're processing the journal also contains transactions that got rolled back. Okay, so a long-running transaction that's done running updates, it's going to be, as it writes stuff out the updates out to disk, it's going to journal those. But it doesn't necessarily know until you get to the end of the transaction. Did we commit that, or was there a failure, or did we roll back for whatever reason? So we know in the journal file whether transactions got rolled back. As we're processing it within Transcend, if we see the transaction got rolled back, we just skip it. So we ignore it. So we don't have to do that. We also go through and, as a trend during a transaction, a record may get updated multiple times. So we can go through and say, okay, we don't need to update the record 15 times. We just need to, what's the final result? And so, very efficient in that respect. Okay. So why might you do log mining? Application modernization, speed other systems to serve workloads, data warehousing, auditing, or migrating from one system to another. Okay. We've had customers that have used this as a way to, as I'm migrating, there's two things. One is that in the process of migrating, customers really need to have access to, what is the data, what is my data, all right? And, they're going to say, how am I going to migrate this table or whatever? But it gives them an ability during a migration process to kind of have access to the data so they can test their migration processes. Then also as a final migration process, it also then gives them the ability to have, okay, I've gone through the process, I've tested, my migration process, and here's final, the end state. So now they can go through and use that as a snapshot for the final migration. Why log mine CODASYL? Again, nobody likes coding in DML, and if you don't like coding in DML, you're kind of out of luck. So yeah, so this allows you to have kind of modern tools. Use modern databases. All right. So if we want to get the data out of DBMS, if we could simply take the CODASYL database and replicate it, create a relational copy of it, then it's like, we can kind of ignore the CODASYL database now. Then we just focus on the world where we have tools and knowledge about how to access it. I think we talked about who's using it in the applications, but keep your OLTP application that remains unchanged. Now you have access to your critical data. So one question might be is I have a really funky database design. So how is it you're going to, how is it you can map my CODASYL database into a relational database? Because I have a weird design, and I can think of one environment where they had a funky design, but the way Transcend works in the replication, literally we just replicate the structures of the CODASYL database into the relational database. So there's no CODASYL database that we can't replicate, guaranteed. Okay. So said we can replicate into a relational database. So who do we support in terms of target databases? So if you're running Oracle Server, we can take your CODASYL database and create an Oracle Server version. If you're running Oracle RDB, we can create RDB database, looks just like your CODASYL database, with all the data and the ability to access it, or a SQL Server. So 3 target environments. And basically, so how does the process work? All right, so we start off with an initial load of the target relational database, and this part's kind of interesting and pretty cool. Okay, so we can actually take a CODASYL DBMS database backup file and use that as our initial load. And so it's almost like in your environment, so are you running CODASYL? Okay, all right. So like DBO backup and then DBO restore. Conceptually, it's like DBO restore to your SQL database. It's like that's kind of cool, But we don't have to go through. There's other log mining for other databases. Where how do you prime the pump? How do you do that initial load? Where maybe what you'd have to do is go through and start off with initial database and go through and modify, every row and not every row, but every row in every table to say, okay, trigger this to get journal to feed this. But we don't have to do that. We'll start with the DBMS backup, and then create the relational database from that and populate it. We take the AIJ, your AIJ file. Now, in CODASYL, it's interesting, contrasting a little bit with RDB. In RDB, there's some locking primitives which are exposed in RDB that would allow one to kind of track where they are. Kind of the last point in the AIJ that's been written, so they can do like real-time replication or more near real-time replication. Here, what we need to do is do an AIJ backup. Okay, so we take an AIJ backup and then we'll process the AIJ backup file. Now, some sites, typically we do that in like 5-minute increments. We've done that at some sites where they've done it at 2-minute increments. We just perform an AIJ backup, we get the AIJ backup file, and that's what's processed. But again, we're not touching the live production database. It's just using a journal file. But apply that to the target database, and you repeat steps 2 and 3 forever. And if you have questions along the way, feel free to ask. So kind of the initial load is really a one step. You do that once, and then then you're done with that. But again, we're not touching the production database, so there's no impact. Doesn't even have to run on the same system that your production database is on. Kind of shows, a picture of this. We have the database. We extract some metadata out of the database, so we know what the schema, we know what the storage schema is. That gives us kind of the definition of what's going to be in the backup file, and then ultimately in the journal files. But we run through, take the backup file, run through transcend, and then initially we create the tables, but then takes the information from the backup and then just populates that. Once the database is populated, then we go through and build all the indices, and then we'll start the continual replication. So the ongoing replication is really the part where the log mining part takes over, and then that just extracts all the changes that were made to the production database. We extract it from the AIJ files, and again, kind of thinking about the equivalent of the DBO command. It's almost like DBO/recover target relational database in the AIJ files. And again, we're not touching the production database, so there's no impact. And then the frequency of that, kind of the lag time between when the transactions occur in the production database and they're reflected in the relational database, are really depending on what the cadence is that you want to apply or perform the AIJ backups.
So Bryan, excuse me,
Yep.
The previous slide, that was the heavy hitter, right? And this would be the one you just showed was a minor hitter. Is that correct? As far as the time, so
This one, if you have a billion rows in your database, this is going to update a billion things, and then at the end of that, it's going to create the indices for that. This process here, the ongoing replication says, I've changed 100,000 rows in the last 2 minutes. Okay, we're applying 100,000 here, and absolutely. But the first one's really kind of, that's something you do once. We have customers that have been running it for years, and it's like, we did the initial create years ago, and no. As I mentioned earlier, we're really, as we're processing, we only look at the committed transactions, so we don't have to go through. It's not like we're going through and updating the relational database. That, oops, see, I got rolled back and roll the stuff back. Before we get there, we don't ship over the stuff that gets rolled back. Everything's replicated in the commit sequence, so that we maintain the consistency of the data. And again, per transaction, only the final update occurs, as opposed to every time the record is modified. Let's see. And then when records are erased, then we go find the corresponding record in the relational database and delete it. The ongoing replication process, again, kind of similar. The database portion is almost material here, but the database, your application and stuff is creating the journal file. So I guess that's important right here. Creating the journal files. You perform an AIJ backup. The AIJ backups perform an AIJ, create the AIJ backup file. Those get processed through transcend. Use the information from the metadata file and update your part of the relational database. Yep.
So this is a great picture. What I was trying to get at earlier is that application in the upper left corner there. That's still in business. That's still functioning. This database, this DBMS database, is also still in business. Am I wrong?
Oh, no. This, okay. This stuff. Actually, everything to the left of my hand here, or my arm here, right? This is what you're doing today, right? And so there's nothing has changed here. This is absolutely, you've been doing this today, and you've been doing it for the last 30 years.
And that's the point. You don't want to mess with that.
Yeah, you haven't affected that. And as we're doing this, so at this point, these are backup files. It's not even, these aren't even live AIJ files.
Yeah.
These are backup files, and we're processing that. So this is completely detached from, there's no impact on we're not shutting down the database. We don't have to, there's no locking. Completely detached. All right. So how do we end up mapping stuff in this next side of it is probably more interesting than this one, but it's just a little bit of terminology. So in CODASYL, they call things record types, and a relational database they're called tables. Fields are called columns, and a relational database. I should probably swap those around because people are probably more familiar today with tables and columns and record types and fields. But then in the CODASYL database, remember those linked lists I talked about? Okay. So, so even in like the relational databases, there's still a way that the records can be identified, which is, in RDB and DBMS are called DB keys. So that kind of, expresses myself. That's a pointer to myself. And then there's, some, we expose really now the set pointer information. Okay, so we have, what's the owner's DB key? What's the next record's DB key? Who's behind me? So, I can walk that linked list in both directions. Depending on how familiar you are with kind of the internals of DBMS, but there's a transaction sequence number, which basically kind of says, what's an age of a transaction, more or less. And then when that record was approximately when that record was updated. So as we go through, and by default, what Transcend would do is say, we'll extract and we'll replicate every table that's in your database. By default, for every table, we'll extract and replicate every column, and we'll even include the hidden column. So, the DB key information, the TSN stuff, and when it was updated, in DBMS. So all this stuff kind of, by default gets replicated. We can go through and then modify, what gets replicated. So we can do a subset of that if we want. Our experience has been there's no cost, really. There's no cost for replicating everything. And at some point down the road, you're going to say, "Boy, I sure wish I had." Well, it's a lot easier just to do it from the get go. So certain applications, your application is a homegrown application or a commercial application? Your CODASYL database. Okay, all right. What's that? Homegrown. Okay, all right. So I can think of in the workstream application, for example, one of the things that it's the CODASYL database. The model is not a very flexible model if you want to make changes to it. Okay, so the people that wrote the workstream application had this great idea. What we're going to do is we're going to, rather than defining all the columns, all the fields that make up this record, I kind of know what the key fields are, but everything else I'm just going to call all data fields. Okay, so that one, defined in the database, this big blob of 1,000 bytes or whatever, that's like all data fields. And then with their application, then they remap that into actually what all the columns are. Okay, so now as we're extracting the data out, it's like, well, geez, now how am I going to, have this one giant field, which how do I break this up? But actually, what we can do is we can actually remap similar to what they do in their programs. We can say, okay, well, yeah, I know, in this table, that this big blob of data you have really contains, this is the part number, this is the part description, and this is, how many units we have, and whatever. Okay, so we can go and remap that so that when we load it into the relational database, all of a sudden we expand that back out, so now all of a sudden you have all the columns that you would expect to have, so you can actually have visibility into your data, not as a big blob, but as actual individual columns and stuff. Field scaling. So, if something has 2 decimal points, but it's stored as an integer, so you can say, okay, well, really that's not, 10,000, it's, 1,000 or 100, I guess. Let's see, conditional data typing. So, we can actually change the data types from the CODASYL database while we're populating the relational database. If you want, you can omit the TSN columns. You can omit the timestamps. These are ones which, I wouldn't feel bad if you omitted those, but again, so little cost for keeping them. If you find a use for them later, may be helpful. If you have corruption in your production database, they might be helpful for you to figure out, what the production database really should look like. You can go through and exclude, say, this table here, it's not worth updating. Nobody wants to report off that or whatever. Or columns. You can exclude, even the next and prior pointers, per set if you want to do that. You can propagate your primary keys into foreign keys. So we can take information from the header record and store the inventory, the part number from the part record into the inventory table. If that's what you want to do. And you have the option to preserve deleted rows, and that would allow you to kind of maintain some history. That one gets a little bit funky because rows can end up getting, the DB keys remember the addresses, the physical addresses. If we delete something, then what ends up having that frees up essentially that DB key, where somebody later on can go and store something and you get another record with that same DB key. But by using kind of a combination of your TSNs and the DB keys, you can rebuild where things were at some prior point in time. Let's see. Oh, so kind of by default, we'll build, like during the initial load, based on your metadata, we'll go through and build a set of indices which kind of mirror the sets that were built into the CODASYL database. But the nice thing is that we have no idea how you want to use this for reporting. So if you have indices which will help your queries be more efficient, you can add indices to it. So not a problem. You want to go through and create views so that you can automatically or give your people that are using the database, they don't have to go through it and write the select statement and say, I want an inventory report. Okay. Rather than going through and select based on the part and the inventory records and then the fields matching, etc. You can define a view that would give them the view of the relationship between different tables. You can add triggers, you can add stored procedures, which again would allow you to have other interfaces into other systems. So it provides a lot of flexibility, things that you can't do in the CODASYL model. All right. So triggers on the target base, notified downstream system. You can maintain an audit history. So, if we delete this record, I want to do, store this information someplace else. In the audit archival, audit history. And views. Typical relational views. You can do it for roll-ups or, it just allows you to create kind of an easier way for people that may be less familiar with your database on how to access some of the data. All right. Let's see. I had a great example. We actually had a customer that was running Transcend for multiple years, and then we actually had to repopulate the Transcend database back from a backup multiple years later. Now, why did that happen? It's like, I thought this thing ran forever and you didn't have to do anything, It's like, so it's actually kind of not that funny. But what ended up happening, they end up having, they had some network issues that went unresolved for an extended period of time. Okay, and so one of the network issue prevented the communication from the CODASYL, from the VMS system running the CODASYL application to the Oracle server. Okay. Now, in the meantime, their AIJ backup files, and they get backed up, to offsite for safekeeping, no problem. Except that the network outage also affected their ability to perform their offsite backups. Okay, so now all of a sudden, what ended up happening was that the outage was so long that there was a gap. Basically there were AIJs that were not recoverable at this point. So that what can we do? It's like, I mean, it's not it was fortunately it's really not a big deal. It's not a big deal to load the stuff, but I would have had some great information for this slide because it would show how really fast our processing is. So we had to repopulate the original, the database, Transcend database from the backup, and so we fire off that job and the job's running. It's like screaming through the stuff, and it stops.
I'm tired.
Can you check with your Oracle server, database administrators? I'm pretty confident that that the Oracle server log files have filled, and they may want to, expand the log space and stuff. So, some amount of time goes by, and then they start that, and then the thing, kicks off and finishes. But it's kind of like it was disappointing. But at any rate, so database 137 tables, 37 million rows. It was 47 minutes to recreate, and I'm pretty sure that data is old. Let's see. It won't be that meaningful. Not people running workstream here, but basically, we take an hour of workstream transactions. And we can apply those in like 31 seconds. I mean, it's very fast. So what are the most fun things about the Transcend has been kind of the customer's reactions when they implement this, and all of a sudden they have access to their data. I mean, I mean, they're very passionate about it because they're like, oh my gosh, it's like, oh, we can do this. Oh, we can do this. Very, very excited. So it's kind of cool. But yeah, I mean, it really solves the problem of how do we get the data out of this database. How can we use current technology? If we want to do some sort of real-time displays of where's our product within the manufacturing pipeline? What's the status of this stuff? Now you can build real tools to get this out to your business. Yeah, and so as I said, some of the customers before this were doing these kind of extracts and really penalizing their production system by just basically constantly having these programs going through and just as fast as they could, which wasn't very fast, but go through and scraping the data out of the database. And they're getting access to the live database versus stale data. And then they can actually do kind of real-time dispatching based on now that you have access to live data with real modern tools, then you kind of get creative in terms of how can I use this? And it's been fun watching people's excitement. Let's see. Yeah, and just the fact that they can use modern tools allows them to have they talk in the presentations here about VSI getting the younger generation involved. Okay, telling a college to, if I got an opportunity for you, we're going to have you write Fortran program to extract data out of a DBMS database using DML, and they're going to look at you and say,
You lost me at Fortran.
I was going to make a joke about that being a foreign language, but I did study that language in school, but then I guess Fortran is a language, so lost some of the punchline there. All right, questions? Sure.
All the way back to the very beginning when you were using all CODASYL.
Yeah.
The way it's arranged and so forth seemed wasteful, from the start. What I mean? The nature of that database seemed like it was, what did you say, 69 is when it all.
Yeah.
Was it reflective of the times? I mean.
Oh, no, absolutely. No, because, rather than having kind of these massive index structures kind of in between, I think there are two things. One is that, from a space standpoint, it's like, okay, we don't have to have these large indices, a separate data structure from our, from our actual records, our live data. So we'll just store this inside. Internally within CODASYL DBMS, through with RDB as well, the DB keys, that we show that they're actually, so the expanded definition is a word, a long word, so it's a quad word in size, but they're actually stored, they're compressed, and so they're much shorter than that in reality. But I think the idea was that I think just the technology at the time was kind of like linked lists are the most efficient way of getting at it. And it's kind of true for if you really know what you're going after, if you can really predefine everything. Okay, but the reality is you can't really predefine everything. Particularly in a reporting side, it's like as customers have access to in a relational database, like they're inventing ways that they never thought were imaginable before. So, but yeah, no, it's reflective of that was kind of the methodology and the thought process at the time, and then I came up with the relational idea, and it's kind of
Sounds good.
yeah, and we have some math behind it to prove the concept. So. Well, if you don't have CODASYL database today, you should all go home and get some so you can.
Well, suppose you had to find one. Where would you start if you wanted to, just for grins?
What's that?
CODASYL. Where would you start if you wanted to build a CODASYL database?
Well, you go shopping at Oracle, and because Oracle will sell you the Oracle CODASYL DBMS kit and stuff.
So they still have that?
Yeah. No, they still sell it, and they still. So there's still maintenance on it, and they're still doing updates.
You still have to pay for that.
Okay. So they're still making money off it.
Yeah. I feature-wise, I wouldn't say that it's been extensively enhanced feature-wise. It still has the same feature set that it had in 1968.
Are there any prerequisites to do such conversion, the transfer? What do I need? I need your software.
Yeah, basically a CODASYL database. We don't run on VAX. So if you're running on VAX, we're
on Integrity.
Integrity Alpha. Alpha Integrity, both those, no problem there.
VSI version.
What's that?
VSI versions. The VSI version. Of VMS we are running. That is support.
Yeah, I think 6.0 and beyond.
Yeah. Any
Yeah.
storage?
Any storage requirements?
Yeah.
No, not really, because these are, we're not making up any more transactions for you. So
No.
so what you're doing in journaling today that's not going to change, right? The frequency, that you do the AIJ backups, that may change depending on, how current you want the data, but it's the same volume. So we're not, there's nothing being added on the VMS side, other than, basically our software and, I mean, obviously, wherever your target database is. So if there's a requirement, it's what, where do you want to put your target database? What's the requirement for that?
No questions.
All right. No,
Thank you, Brian.
you're welcome. Welcome. So, thank you.
Okay. I send you an email with a request for the presentation.
Yeah.
And you can reply.
Yeah.
And then I will come back with the plans
Perfect.
next week.
Yeah. We might schedule something we.
Yeah.
Very interesting. I mean, I know all those terms and everything, and I'm thinking, okay, now I understand, what's behind
Yeah.
your tool and everything else, why is it used?
Yeah, as I said, it has been fun, just kind of watching the customers' reactions. It's a, it's almost like a disbelief. It's like,
Yeah.
oh yeah, no.
They think they are on that end.
Oh yeah, absolutely. No,
Somebody
they're
knows
like,
a solution.
yeah, no, it's been fun.
Well, the alterations that they would have to do to get, changes to the CODASYL database and the applications that are touching it probably were a total pain in the rear end. You mentioned that.
Yeah, and that's just not feasible. I mean, that's the thing. And again, it's probably a situation where, if they want to go that route, then, kind of the effort and the resource they have today, they have to hire the COBOL programmers or whatever to do that.
I was COBOL programmer 1972 to 1974.
Yeah.
Giant got in Boston.
Yeah.
I mean, it was actually.
No, there's plenty of COBOL work today.
Yeah.
There's a ton of COBOL that exists. And
You don't need to find the guys who want to do it.
I know, that's it.
Right, young guys.
Yeah.
You get calls every now and then.
Yes.
Yeah.
That slide I was asking about, where you drew the line, the older stuff is over here. What I was in my mind before that was, okay, when we finish this, we're not going to have a CODASYL database anymore.
Okay, so I think Rob was looking at a situation where the customer wishes to migrate off of CODASYL. Okay, and so in that case here, they continue to do the replication and they have their replicated copy of the database. And that's ultimately either where they're going to migrate to, or more likely they're going to basically use that as a data source for populating whatever the new system is.
And future development of the applications would be interacting with that. New stuff.
With the new thing, and the CODASYL stuff would just they're done with that. But they have all the they have what the CODASYL database. They have access to the CODASYL database, which allows them to do the the migration, because otherwise it's like, okay, we're gonna do it. I want to migrate off, but it's like, but I still need the data. And so this kind of gives you access.
We think there will be a CODASYL version on x86?
Yes.
I still think that.
Oh, no, yeah, quite frankly, the CODASYL version could very easily predate the RDB version.
I heard that already also.
Yeah, because, basically the core engine itself.
Yeah.
Is very common. And so, you can kind of think the RDB database, internally, there's a lot of consistency in parts of the IOs, the journaling, the CODA, if you're familiar with that, is very common between them. But the RDB database has a lot of interfaces, many more interfaces than the exec and stuff. So, there's a lot more complexity. But basically, you have to, in essence, you have to port the CODASYL database. And that gets your engine working. And then for RDB, then they build the car around it. But CODASYL is just sort of much smaller component of it.
A transcend is your code.
Yeah.
So that is your property.
Yeah.
So managed to figure out how the CODASYL works internally, Windows records and developments and that kind of stuff.
It's really figuring out how the journaling works. And then also it's kind of the mapping of that into relational database.
Yeah, but you have to figure out what the transaction look means, in fact, the bits and the bytes. Yeah,
so within the journal file, you have to figure out, identify each transaction. So what's the start of the transaction? What's the end of the transaction? So it's either going to be a commit or a rollback. To mark obviously the end of it. So that's the transaction. And you figure out all the records. That have changed within it. Now, each record has the complete structure of the contents, right? You need to figure out. So within the journal file, there's two types of updates in the journal file. There's a modify, and there's a delete. Okay. So in the modify, notice that there's no inserts. Okay. So modify is either, essentially, on the transcend side, as we're replicating that, we treat that as essentially an upsert. That if the record doesn't exist, create it. If it does exist, then if it doesn't exist, insert it. Yeah. If it does exist, then update it. The deletes are a little bit tricky because on the deletes, all we have is a DB key. So we don't actually have anything, nor would we necessarily. I'll lie a little bit. But even if you had the full record that got deleted, you wouldn't necessarily have a guaranteed unique keys for that other than the DB key. So one of the challenges that that we solve within transcend is then given a DB key, what table is that DB key in? So what do I delete? Okay. But we're able to map that DB key to a table, and that tells us what table when you go. Then we know that the DB key stored in the target table, so that we can go through and delete that row. Okay. But
I look forward.
Any feel for how Oracle's doing with the RDB update for x86?
I haven't talked with Kevin that recently. It always seems like it's close.
How close?
That's
what they say. Time.
No, that's $1 million question. It's like, I'm not sure. I'm not sure what the.
Obviously,
I need to set up.
What's that?
I need to set up.
Oh, go ahead. I'm sorry.